Hello friends, and welcome to my channel. Today I'm going to show you how to solve this easy but difficult problem. And if you look at this, you can easily make a guess that x is 2, which is one of the solutions, and that will be correct because this is 9 plus 16 is equals to 25. So one of the solutions for x is actually 2, but today I'm going to show you the difficult part, which is actually solving to get this 2 and not just making a guess. So to kick that off, I'm going to start by writing the problem. 3 to the power of x plus 4 to the power of x. This is equals to 5 to the power of x. Next, I'm going to 4 to the power of x to the right hand side. We're going to have 5 to the power of x minus 4 to the power of x. Next, I will divide both sides by 3 to the power of x. 3 to the power of x, and this is 5 to the power of x divided by 3 to the power of x minus 4 to the power of x divided by 3 to the power of x. Okay, and 3 to the power of x over 3 to the power of x is simply 1, and this will be equals to, I can easily do this by indices, 5 over 3 all to the power of x minus 4 over 3 all to the power of x. And we know that x is same as x divided by 2 times 2. So I'm going to replace this x with x divided by 2 times 2 in this problem. So you're going to have 1 is simply equals to 5 over 3 to the power of x divided by 2 times 2 minus 4 over 3 to the power of x divided by 2 times 2. And if you recall in indices, let's say p is raised to the power of n m. This is the same as p to the power of n all to the power of m. And we're going to apply this to this problem we have here. So we're going to have, this will be 1 equals to 5 over 3 to the power of x divided by 2 all to the power of 2, just as what we did here, minus 4 over 3 to the power of x divided by 2 all to the power of 2. Next, we can say let a be equals to 5 over 3 to the power of x over 2, and let b be equals to 4 over 3 to the power of x divided by 2. Alright, so if we do that, we're going to have that 1 is equals to a squared minus b squared. Okay, and this is same as a plus b, a minus b is equals to 1. Moving forward, we're going to find two numbers, they could be fractions, that can multiply each other to give us 1 to help us solve this problem. And there are so many numbers that can do that, like 1 over 2 times 2 will give us 1, 3 over 4 times 4 over 3 will give us 1, but there's only one correct value that we need. And to find that value, I'm going to show you how, because this is where the trick comes. How to find one of such numbers: you're going to add the numerator here 5 plus the numerator here 4 and divide it by the common denominator. So one of those numbers is going to be 5 plus 4 divided by 3, which will give us 9 over 3, and this is 3. So one of such numbers is going to be 3, and that already informs us what the other number will be. So 1 is simply going to be 3 times 1 over 3. So these are the two numbers we're looking for that can replace 1 to help us solve this. So let me rewrite the problem. So we have a plus b, a minus b, and this is equals to 3 times 1 over 3. And a is positive, b is positive. And so by comparison, we already know that a plus b is equals to 3, and a minus b is equals to 1 over 3. So now we have to solve this simultaneous equation. And by adding these two equations, it's going to imply that a plus a will give us 2a, b minus b is 0, and this is equals to 3 plus 1 over 3. So this will give us that 2a is equals to 10 over 3. And if we divide both sides by 2, we will obtain that our A is simply 10 over 6, which is 5 over 3. So we've now found out what A is, and we don't need to find what B is because A is enough to help us solve for X. And here we have that A is 5 over 3 to the power of X over 2. So let's put that down here. So we have that A is simply 5 over 3 to the power of X over 2, and this is equals to what we have here, just 5 over 3. And we can put this to the power of 1. So since the bases are the same, we can equate the powers. So we have that X divided by 2, this is equals to 1. And by cross multiplication or multiplying both sides by 2, we obtain that X is simply equals to 2. And that is how to solve this problem without having to guess. So we've been able to solve this problem. And a very quick catch here is for you to note that this solution works for Pythagorean triples. So this particular solution is an easy way to solve for X if you have Pythagorean triples. And I'm going to do yet another example here, and later I'm going to give you a more general solution. So for a second example, we're going to solve it in the very same manner as we solved the first one. We have a to the power of x. This is equals to 17x minus 15 to the power of x. Next, we'll divide both sides by a to the power of x, and we'll have here will be 1 is equals to 17 to the power of x over 8 to the power of x minus 15 to the power of x over 8 to the power of x. And this is same as 17 over 8 all to the power of x minus 15 over 8 all to the power of x. And as we know, just as we did earlier, x is same as x over 2 times 2. So if we apply this here, we're going to have that 1 is equals to 17 over 8 x over 2 times 2 minus 15 over 8 x over 2 times 2, and this is simply, open the big bracket, 17 over 8 all to the power of x over 2 all to the power of 2 minus, open the big bracket again, 15 over 8 all to the power of x over 2 all to the power of 2. And here we can easily say, let 17 over 8 all to the power of x over 2 be equals to our a, and then let our b be. So by so doing, we have that 1 is simply equals to a squared minus b squared, which is simply a plus b into a minus b. And now we're going to find two numbers that are going to multiply each other to give us 1. And the trick, remember the trick we did last time, we're going to add the two numerators and divide by the common denominator to get one of such numbers. So we have 17 plus 15 over 8, and this is 32 over 8, which is 4. So 4 is one of such numbers. That means that 1 is simply 4 times its reciprocal, which is 1 over 4. So we're going to replace 1 with 4 times 1 over 4. So we have that a plus b into a minus b is equals to 4 times 1 over 4. Next, we transform this to a simultaneous equation. We'll have that a plus b, since they are both positive, is equals to 4, and a minus b is equals to 1 over 4. So we solve for a the first time. This time, let us solve for b. So if we subtract these two equations, we have that a minus a is 0, b minus b is 2b, okay? And we have this equals to 4 minus 1 over 4. And if you solve this out, this will give you 15 over 4, okay? So we have that 2b is equals to 15 over 4. Divide this by 2, divide this by 2. You will obtain that b is equals to 15 over a. And having obtained b, we don't have any need to solve for a because b will be enough to solve our problem. Any of them will be enough to solve our problem. And b is 15 over 8 to the power of x over 2. So we have that b is 15 over 8 to the power of x over 2, and this is equals to 15 over 8, and we can say this is to the power of 1. Okay, the base are the same, so we can equate the exponents. So we're going to have here that x divided by 2 is equals to 1, which simply implies that our x is equals to 2, and that is the solution to a problem without guessing. And let's take note that this method I just showed you now works for Pythagorean triples. Okay, because if you look clearly, 8, 15 and 17, these are Pythagorean triple, and what that means is that if you have a right angle triangle, you can have 8, 15 and 17, and this is absolutely correct. And in my coming videos, I'm going to show you how to solve this problem even if the numbers are not Pythagorean triples. I'm going to give you a more general solution to this problem. So guys, please, if you have any comments, if you have any disagreement, please drop it on the comment box, like, subscribe and share, and see you in the next video. And if you're into complex numbers, I have a lot of different kinds of problem already solved here for you to go check out. Thank you very much, guys.